All right, welcome back, everybody. We are moving into Project 11 of the Arduino Starter Kit. This one is our crystal ball, and really, realistically, what it is looking for a different message each time. That in the case of the booklet, using the tilt sensor, every time we tilt the board, we'll get a new message. The first thing I do want to point out is I have changed that tilt to a pin. Everything, or to a switch, I'm sorry, to a button switch. Everything else is absolutely 100% identical. I just removed the tilt sensor and put in a pin. The tilt sensor that comes with the kit, for me, sorry, I'm getting kind of over a cold. That tilt sensor just does not work at all. It doesn't stick with the board, and every time I would need to show you guys something changing in the LED, I would have to pick up the board and switch it around. That's not the purpose of this project. The purpose of this project is to learn how to work with the LED. So basically, every time in this board, every time you press the button, you'll get a new message, right? And we saw that in the code earlier, but minimal amount of change. Again, the primary purpose of this project is to learn how to work with the LED, not try to figure out how to make your tilt sensor work. But you do whichever one you want. Again, the board is identical with the exception of the switch. So with that out of the way, you'll notice we have a ton of wires in here that look very confusing. So the first thing I've done is I've removed the positive and negative, simply because I didn't want the LED turned on, and I wanted to avoid the additional wires in here. We'll turn it on here momentarily after we walk through everything to see it actually working. But for now, what I want to do is I want to kind of start at the bottom of the board and walk our way up. The first thing I want to point out is this very bottom pin on the LED, which is the LED negative, goes out to our ground. And you'll notice with this yellow wire, let me see if I can hold this board down a little bit to show you the yellow wire here. And you can see that the yellow wire goes from the LED negative, pin 1, over to the ground. Now, from there, let me go ahead and move this back and focus. The very next LED pin, pin 2, it's LED positive, meaning it needs to have the power, the positive power fed into, and you'll notice that this red wire is on this inside track. So we're bringing power into pin 2 of our LED. So pin 1 is the LED negative, goes to ground. Pin 2 is our LED positive, comes in from our power. Now, the very next pin that we're going to be looking at, this third pin right here, this third pin, it's our data pin 7. And data pin 7 can be used to either dim or brighten our LED. And you'll notice this red wire underneath that's coming from our potentiometer's output is coming directly into this third pin, into our LED. And what this allows us to do is we can now use our potentiometer to brighten or dim our LED. And that's exactly what this pin is doing into D7 of our LED. Now, when we're looking at the fourth pin, in this case D6, our data input 6, you'll notice that our orange line here is coming out to pin 12 on our Arduino board. You might not be able to see it with this gray wire in the way, but orange is going into pin 12. And if you recall, pin 12 was the very first argument that we passed into our LCD constructor And what that means is, if you recall from the code, we did an include of the liquid crystal header, which also included, which when we compiled, brought in the symbols for our liquid crystal library as well. And this pin right here for the digital pin D6, mapping from 12, our Arduino 12, to our LED 6 is handled for us by that liquid crystal library. So we don't even need to worry about it. We just need to make certain that we match up the number, the pin identity or ID that we put in as the first parameter is plugged in to our LED's fourth pin, in this case D6. Okay? Now, from the D6 moving into D5, right? So here's where, remember, our D7 is our potentiometer's input, so we can dim or brighten our LED. Our D6 is our pin 12. And now our D5, we just put that out directly to ground. We're not really using it. So even though in our constructor for our LED, we put in the additional data pins, right? We used four, what was it? 4 or 5. Let me look really quick. We used 5, 4, 3, and 2 for our what was it? First, third, fourth, fifth, and sixth parameters into our LED. And we'll talk more about these later, but pin 5 was referencing our Arduino board in the constructor, not the D5 here. So D5 for our LED, we're just going directly out to ground. We're just grounding that pin out. Now, next, as we start moving up and we move into D4, you can see here that our D4 pin is connected by this gray wire to pin 11 on our Arduino board. And if you remember, when we passed in our arguments to the constructor for our LCD, 11 was the second argument, which means that the LCD or the liquid crystal library, when you create an instance and you pass variables to the constructor, that means it maps whatever you provide as that second argument. In our case, we provided 11, which means pin 11 on our Arduino board. It is going to match that up to the D4 on the LED, right? So whatever pin we pass as the second parameter, in our case we passed 11, pass whichever one you want, but we just passed 11. It's going to match that voltage to the D4 of the LED. Okay? So the next thing that we're going to look at, kind of moving up the board, and it gets a little confusing up here. This gray pin, or this gray wire right here, that is coming from our D5. You can see that the D5 is coming out. I'm going to follow this gray line a little bit. D5 is coming directly into this pin on the LED. Right, and now if we look at these pins right here, we'll talk more about the specifics here in just a second, but you'll notice that we're now looking at pin 5, 4, 3, and 2. And if you recall from the code, we passed in as the third, fourth, fifth, and sixth parameters pins 5, 4, 3, and 2. And so what's happening here is these pins are being married up to various pins within that are required within the LED. Now, you'll notice in the booklet, they talk about the registration pin, which we have pin 3, which is this orange line kind of going through here, kind of comes up. Pin 3 is married into our RS pin. And the RS pin of the LED, I'm not 100% certain what it does. It is obviously the register select, but trying to power on or off the pin 3 on our Arduino, we don't need to worry about it. The liquid crystal library takes care of that, right? And it's the same exact thing when we look at pins 4, 5, and as well as 2, right? We have pin 4 right here going from the yellow. The pin 4 is coming over into the read write pin on our LED, and this just sets the LED to, you know, either go into read mode or write mode. Read mode would be something if you have the keyboard installed, but this pin 3, again, the liquid crystal library handles how this behaves. It handles all that for us, right? So we don't even need to really worry about much. We just have our LCD variable and we can just write, and we don't have to set any of this up. It's all set up for us in the liquid crystal constructor. Now, that all of these pins in here going into the LED, as long as the 3rd, 4th, 5th, and 6th variables are matched up to the appropriate LED pins, really at that point you don't have anything else to worry about. That's pretty much about it. The only thing that is of some consequence, and they do have another wire in the booklet, but I'm just going directly from the power into the 15th pin, which is the VCC pin, into the LCD, and that really is just a power supply. That's about it. Even though they had another wire, the wires on my resistor were long enough. I could just pull in power directly into pin 15. So there's one extra wire in the like I said, in the booklet, but I'm trying to minimize wires in here because there's so many of them. But that's all that's happening there. Here again with the VSS, the top is really more or less an additional LED negative, and you can see here that this is going directly out to the ground, right? So pin 16 from the LED goes directly out to the ground. So as long as you have your grounds set up and you have your input power coming in, the rest of these wires that get plugged in, you just have to remember that the 1st and 2nd parameters in the constructor go to the 4th and 6th pins, and then the 3rd, 4th, 5th, and 6th parameters go to the appropriate pins over here, regardless if it's the read write pin, the RS pin, the enable pin. You just need to make certain that they kind of match up. That's it. But again, even though these wires are complex and there's a lot going on with the electrical circuits underneath, that's where the liquid crystal library again comes in, helps us out. So as complex as this looks, if you recall how easy it was in our code to interact with the LED. So kind of enough about that being said. It really is just matching up the wires to go to from the appropriate pins on our Arduino to the appropriate pins on our LED. That's about it. When it comes to our potentiometer, there's nothing new here. You've seen this all before. The very top pin gets power directly. Let's see if I can. You can see this little blue wire pulls in power. The orange line here pulls power out to the ground, and then the potentiometer's analog output goes to the 3rd pin, or data pin 7 on our LED, right? And that's for dimming or brightening our LED. That's about it. The only other thing here, obviously, we changed out the tilt sensor for the switch. We're bringing in power. It's just a switch. You've all seen this before. And when we close the circuit, the output of the pin, it's going to hit the resistor, come into our ground, right? Protect our circuit through the resistor. And then that output information is going to come directly over into pin 6. Now, pin 6 is what we're going to be using in our code to read whether or not the user pressed the button. If they press the button, give a new message. And that's about it, right? So the top part of this you've seen before, pretty much all the way up to, above here, you've already seen it. Below here, it's really just kind of mapping whatever our first, second, third, fourth, fifth, and sixth parameters into our LCD constructor and matching up to the appropriate pins here, making sure that the ground and power are lined up correctly on our LED. And that's pretty much about it, right? And again, we saw how simple the code was. So what I'm going to do now is I'm going to go ahead and plug in a 9-volt battery, twist this around, and we'll see some new messages. So as soon as I plug this in, we'll be right back. All right, we now have our board powered up. You can see the initial message that we have in our setup code. Ask the crystal ball, right? Ask it something. In our case, it really means, hey, press the button and get a new message, right? So let's go ahead and just take a look at that. We hit this, we'll hit that random number generator, and we'll get a new message in here. It says no. I don't know if that's a good thing or a bad thing, but regardless, we hit it again. Better, and most likely. Hopefully you asked it something positive. Right, we can keep doing this. Sometimes the random number generator is going to hit the same number twice in a row. Right, and maybe our luck is looking up. Who knows, right? It looks better with certainly. Again, yes, doubtful, less positive, I guess. Ask again. Yes, I mean, you get the idea, right? And again, this is why I'm using the button or switch as opposed to that tilt. I think there's absolutely no purpose whatsoever in learning the LED by tilting this thing. It's irrelevant. Just pressing a button gives you what you need for this lesson. So anyways, let's try to leave on a better note than unsure. Let's go with certain. I like that. So that's it. I know that this was a little bit of a longer video for the boards than we normally do, but there was a lot to cover in this board, just simply because of the number of wires and understanding how to really marry up the Arduino pins with the LED pins and understanding how all of this was pretty much taken care of for us via the liquid crystal library. I think that those are the big takeaways. So anyways, that's it for this board. And I know that it's an interesting one. I hope you play around with this because it is fun, and this is really where we're starting to see some real world examples of the Arduino coming into play. Almost every circuit's going to have an LED. So anyways, with that said, hope you enjoyed this combination of videos for the Project 11, and we look forward to seeing you in the next video. Take care, everybody.